Hi everyone, welcome back from the break. I hope you had a good one. So we're going to continue our program now of prevention and how to stay out of the hospital. And I have the distinct honor of welcoming the operations manager at Generation PEP, who also happens to be Swedish track and field royalty. So Carolina Klüft, welcome to this seminar.
Thank you so much. It's a pleasure to have this opportunity to talk to you guys for this half hour about children's health. Like the introduction said, I'm Carolina Klüft, former athlete of track and field, but that's a long time ago. So now I'm focusing on children's health. So yeah, really looking forward to this.
I just have to ask Carolina, as preparation, I took a quick look at your Wikipedia page, and basically all traces end in 2011, after around the time you retired. What have you been doing since then? Briefly.
Briefly, yeah, I'm still an heptathlete. I would say I've done many different things. I've been studying, I've been working with television and sport in the Olympic Games. I've been writing a book, and I've been working here at Generation PEP. So I do different things, but this is my main focus.
Wonderful. Well, it sounds like you've got a varied plate. So we look forward to hearing about children's physical health in Sweden. The floor is yours.
Thank you so much, and I will start by sharing my screen with you guys. So let's see here if we can get this to work. Start. I'm hoping you see the screen now.
It's good.
Well, I will start talking about the problem of children's health in Sweden by some facts, and I will later on talk about what Generation PEP is, what kind of organization, and what we do, of course. So in Sweden, we have, of course, an obvious problem in many other countries that we don't have equal health. So it's different factors behind that will decide how good opportunities or possibilities you will have to really get a good health and a long life. A few of those factors we have right here. It's where you live in Sweden will be part of it. What kind of education your parents have will decide what kind of good ground you will have yourself of getting a good health. Socioeconomic factors are obviously one of the biggest factors behind unequal health. If you have lower income and you live in social areas where it's harder and more difficult to be included in the society, you will have more difficult and you will have less opportunities to be physical active and to have better food habits. Also, where you are born, what country you're born in will have impact. There are more factors, of course. It could do with what gender you have, what age you are in. It could also have factors that if you have some kind of disability. So, of course, there are many factors that decides how many obstacles you have in front of you for having the opportunity for a good health and good living habits. And so few children in Sweden are physically active enough, and teenage girls are those who move at least. We can see in our reports that we do every year that 2 out of 10 children reach the recommendation of 60 minutes of physical activity per day average. And we don't see any, we have also in this pandemic, we also see, of course, that even more children have been more sedentary and have more screen time during this pandemic. So this was really a big problem before and are now maybe even worse. So we have a big challenge in front of us to change this around. We also know that according to age, the youngest children are more active and have more physical activity, but the older you get, and when you are a teenage girl, you're having more difficulties and not the same opportunities to be physical active. So it happens a lot around these years when you go from in Sweden 6th grade up to the 7th grade in school, we can see a big decreasing amount of children that are physically active enough. We can also look at the food habits, and that we have challenges there as well. We can see that only half of children eat as they are recommended according to fish and shellfish and so on. And also when we talk about vegetables, we just see that 5 out of 10 eat vegetables every day. And so if we look at the vegetables, fruits and berries, only 1 out of 10 children are reaching the recommendation of 500 grams per day for children over 10 years old. If you're younger than 10 years old, you should eat 400 grams. And we can also see that income are affecting the possibilities to be active on your free time. This is a question about if you go to any physical activity after school, and with more, even if you look at income, you can see there are big differences where children to parents with low income, 56% answers yes in that question if they have frequently attend to organized training or physical activity. But in high income families, that number is 85. So these are big differences that we have to do something about. We also look at time in front of different kind of screens or tablets, computers, TV, and so on and so forth. And this is out not on school time. This is their free time. And you can see in the middle here, you can see that 50% of the youngest kids, 4 to 6 years, it's 1 to 2 hours per day. So the majority, even though we have recommendation up to 4 to 5 years that you should only sit maximum 1 hour per day. And that is WHO that has these recommendations. And you can see that the bigger ones, and this number is even higher in this year's report. These numbers are from 2019. If we look at this year's report, you can see that the yellow one to the right in the screen, that are 23% sitting of the teenagers over 13 years old, sitting 23% sitting 5 hours or more. That number this year is 30%. So we can see it's increasing in this more children sitting more, and the teenagers are the ones having a lot of sedentary time. And so if you combine these two with both physical activity and food habits, only 14%, and this number this year during this crisis are even worse, 9% from this year, of children that reaching both these recommendations. So it's a big challenge for us to work with this. And why does it look like this? Well, the norms are shifting, of course. It's more difficult today. We can see that, for example, to go back and forward to schools in an active way by bike or walking has been decreasing since the 90s with half. So 50% less today go to school in an active way. We can see that if you go to a store today, the packages are bigger. There are more choices, and also more choices, of course, in bad food habits. So it's difficult today to make good choices, and we can see that we have went from a more active situation to a more sedentary behavior, and we can see that from year to year if you look at the all averages. And this has, of course, consequences for both individuals and society. You know that physical activity is the best way of, having a lower risk to develop different kind of diseases like depression, diabetes type 2, and also cancer can be really lower risk if you have good physical activity and good food habits. We have also seen that obesity has been increasing since the 1980s. If you look at the whole population, it's 3 times more today. But if you can also look at special ages, and you can see, for example, in teenage boys, the number there is maybe 6 or 7 times bigger today than in the 80s. And of course, you know, this in the end make the life shorter, and we can see that the life expectancy are depending a lot of what kind of education you have, but it will also be affected by your food and physical activity habits. And this costs, of course, many, many billions every year. This is one number according to obesity, but you can count this in many different ways, of course, but it costs the society a lot of money, of course. And so we think we have to do something about it, of course. And we try to do joint efforts on all levels in the society to make a big difference. And that's why Generation PEP once was founded by the Crown Princess couple, Crown Princess Victoria and Prince Daniel. They started Generation PEP with the vision that all children and youth in Sweden should have the ability and desire to live an active and healthy life. And we started now almost 5 years ago in 2016 and has been working really hard since then to change this around. It's not an easy task, but it's really something we have to do. The only failure will be to stop trying. So this is what we work with every day in Generation PEP. So we try to work with whole society. We try to be there where we see that children are. We try to affect adults that are close to children and that can have the opportunity and the power to change the circumstances around the child so that they can, and we can move from having a more sedentary norm to a more physical, active and good food habits norm. So we really try to make this change. So we have to be around schools, of course, because out of equal perspective, we have all children there in Sweden. So schools are, of course, a very important place to be and to make schools work with health. That's not their main cause, of course, but it could be very important also for having good studied environments around them. And we work also, of course, with the start in life where the children are really small. So we try to work with, you know, when you come to the child health care in the beginning, and when as a new parent, you will have knowledge and get good inspiration and facts that you can use early with the child. And also in preschools, of course, we try to work and make them have physical activity and good food habits as something they work with. And we also work with the free time that has to do with physical activity in different clubs in Sweden. It could be parks, safe places to move around. It can also be to be able to move actively and not have to travel by car or other transportation that are more sedentary, for example. And we also work against the choices you made as an individual, both as a parent, but also as a young person. But mainly we focus on the parents that goes to the shop or need, you know, inspiration and knowledge to make good, healthy choices. And of course, decision makers, we have to work with every decision maker in different levels in the society to move this around. And we also try to build up a national movement so that we are many organizations, companies, clubs, individuals, that municipalities, whatever, that tries to work with this question and want to make a change. And we try to put them together and try to find each other and do good things together. So we work with this movement, you know, to be many, we have to do a lot of different things, and every single thing that you do for young people today to give them better opportunities to move around and to eat good, then we try to see that and help out and have this connecting environment. But where we see that we can really do an impact, we also start our own initiatives or initiatives together with a company or with another organization or another partner. So we have initiatives that really tries to make impact in children's life. And we have made almost 40 initiatives since we started, so in different ways and in different arenas. And we also try to be a voice for the question, of course. We want to spread the word that this is important. We try to get out with facts and knowledge, but also to inspire to make changes, both on individual level, but also the society level. So we do that in many different communication strategies to really spread the word, and so that decision makers also can put this question higher up on their agendas, because that has not been the case for a long time. And so we're many. So far we are around 500 organizations in our movement, and more are coming in every day that want to do something. And sometimes you're spreading the word, but just sharing our newsletter or sharing different facts that we spread to them, or they do bigger things that might even start initiatives together with us. We have over 1,600 PEP schools, schools that are using our free systematic kind of tool that are digital and can help schools to really make a change and have more physical activity and better food habits according to what happens in schools. We have 40 initiatives, like I said, and now we also have added preschools, because now we also have a support digital tool for preschools to work with these questions. And over 700 preschools has already signed up to use this digital tool since just a few weeks back. So the engagement and the passion for these questions are maybe what keep us really having a lot of energy, because even if the questions are and our questions that we work for are sometimes very, very challenging, we see that there's a lot of passion and a lot of willingness to make a change around in our society. So a few examples I will end with what we really do, so you will get a better picture of what I've been talking about. So Generation Prep School, like I said, is an inspiration bank. It's a network, but it's also, you're also able to certify your school to be a Generation Prep School. So it's really about planning and evaluate what you do in schools, and you also get a lot of concrete solutions and tips how you can really get physical activity and food habits to be like natural during the school day. Like I also said, we now have a free digital toolbox for preschools. It's not really the same as schools. This is more for preschools and out of their situation and how they work. So this is brand new, just a few weeks old, and we've been testing it for some time, but now we have really released it for every preschool in Sweden to use it for free, of course, because that is something that is really important, so that it should be easy to use and not a lot of costs and expenses to use it. It should be free for everyone to use, of course. So this will be equal and not for just those who have the opportunities. So this is free, of course. We also work with we have a children's book that we have had since a few years back. We have delivered that to young 5-year-olds when they come to their health control, and they got this book for free. But now we have developed out of the book also kind of a conversation tool that the nurse can have as a support to talk about these questions, because sometimes it could be really difficult to talk about physical activity and food habits. So this is kind of a supporting tool for nurses meeting these parents and children, and to talk about this in an inspirational and good way. We arrange something that we call Pep Dag or Pep Day every year. Now, obviously, because of the pandemic, we have not been able to do this because we gather over 10,000 people during a day in Hagaparken outside of Stockholm. But we will also release this as a tool for anyone to do a PEP day around Sweden. It could be a very small one or a bigger one, but you just have to follow a few criteria that we have put up, and you can call it a PEP day, and everyone can arrange it around Sweden if you like. We also have something called PEP Park. It's also something that we have released as a tool for municipalities, or it could be housing companies or other building companies that want to make good parks with movement and knowledge for the whole family, and for something for every child that they can find to do. So it's popping up a few pet parks, and we'll we have 2 now, but it will pop up more during this year. And this is one example from an initiative that we have together with a company. This is a company that sells glasses. And first, when they came to us and wanted to do something, was like, what can we do together? But of course, me myself had glasses when I was a child, and sometimes it was really hard to join the others playing around because you were so scared and afraid that you will lose the only pair of glasses that you had. So this is really about giving out free activity glasses to the ages of 5 to 12 years old. And you can have 1 extra pair of glasses that are strong enough to hold for physical activity, and you don't have to be afraid. And we have that they will break or you will lose them. And we have some really good stories from parents that for the first time can see that their children can really be part of playing, be part of swimming, be part of doing things that they didn't do before with these new glasses that are, of course, they're special for their defect that they have. So this is one example from the society, from the company's side that we do. Well, that was a little about Generation PEP and the question about children's health. We have big challenges in front of us. We have, it's kind of, sometimes it's hard to get all the new reports and see that this is something that children are getting more and more sedentary and eating not good enough what their bodies needs. But like I said, there's a lot of people, companies, municipalities, organizations, clubs, and so on and so forth that really want to make a change. So we are still optimistic, and we think that we can make a good change and great change together with the whole society. That is the only way if we want to change this around. Thank you very much.
Thank you very much, Carolina. That was a really hope-inspiring and interesting presentation. I like and am a little bit, feeling this feeling of being newly informed by all the statistics. So that was enlightening. Basically, all the questions I started listing, you answered. So I'm just going to have to ask you for elaborating on certain points. One thing I thought was particularly interesting was this trend observation that it's mostly teenage girls who decrease a lot in their physical activity. What are some of the reasons behind that?
Well, there are different reasons, and it's not only girls, I should say, that those are the ones that move less. But there are many things happens, when you go from, first of all, I think you change schools. So you see that you have naturally more physical activity in the younger ages, and also you have schoolyards that are more inspirational when it gets to physical activity, which you don't have when you come to high school, if you would say that. And I also think, this studying and the school maybe takes more time. We also see that around this age, 11, 12 years old, a lot of children quit their physical activity on their free time. So of course, the physical activity maybe you had during the weeks, you stop with. And we can see that girls especially are more sensitive if a friend stops with the physical activity or their sport. Girls are more sensitive to that and also quit because of it. They want this social maybe more than the competitive situation. Now this is of course very general, so this is not for everyone, but you can see that girls are a little bit more sensitive. So when friends are stopping their sport, they do so as well. And also we have, of course, more time in front of screens and tablets and so on that are more into children's life the older they get. And so sometimes it's, of course, hard to, we don't say that it's bad just per se, but what we can see in our study is that children and young teenagers that has more time sedentary in front of a screen have less time to be physical active. So there is some kind of competitive strength between these two. So if you put a lot of time here, you will obviously have less time for something else, and physical activity are usually being affected by that.
Yeah, that is definitely food for thought. As you've probably noticed, a lot of the focus today is on how to enable things through technology, and perhaps that's a little bit of a challenge to negotiate here, where we're trying to get kids to, I guess, move more without technology being involved. But is there a technological component to the work Generation PEP does?
Yeah, it's not technology per se, it's sedentary maybe, and it's not bad to have sedentary technology time. That's not the case. I mean, we're not saying it's forbidden to have, I mean, my kids are sitting with screens sometimes, but it's just good. You don't eat candy every day, so maybe you should also know that you have to sometimes have, you have to say this and this, and maybe sometimes you have to have a break. So take a break in 5-10 minutes, you will also play better maybe, and you will get, you know, new focus and so on and so forth. And you can also use technology to move around. You can be filming, you can be outside using the cameras, you can do a lot of things. You can have apps that will also inspire you to move around. So it's not technology per se, but it's you have to have limits. You cannot sit the whole day sedentary with your screen, because then you will not have time for physical activity. And it doesn't have to be train real hard. I mean, I've been training really hard, of course, and it's not about that. It's about these small breaks, 5 minutes here, 10 minutes there, take a walk between. So it's not about being, you know, a training athlete. It's about having this breaks from time to time when you have a lot of sedentary behavior.
As an ergonomist, I'm very happy to hear that you have that view of it. I was thinking a bit about how in the beginning you talked about how the opportunity for physical activity has something to do with your socioeconomic situation, and that's easy to kind of picture. I was wondering a bit, though, about the attitudes towards physical activity that you have perceived from the children. Like, maybe this varies across ages, but what kind of feelings and attitudes do they have towards you should move more?
Well, we can see in our first report, we have a segment in the report talking about motivation and if you have the willingness to move around or be physical active. And what you can see that most children, you can also see most children, the majority of all children want to have more physical activity, you know, in the schedule in school than they have today. So we can see that there is motivation, there is willingness from the children. They want to move around, but they don't. I met teenage girls, I talked to them, and they say sometimes if you're not very sporty, if you don't want to have a sport, if you quit your sport and you are a teenager, you don't see where can I be physical active? I'm too young for the gym. I don't want to be an outside gym. I don't have maybe a friend to do something. So you don't really see what can I do? So we need to sometimes, now we're making a big study talking to teenagers specifically, what factors stop them and what factors also made them be physical activity, to really understand what they need so that we don't do things that they don't even care about. But we know that the motivation and willingness is high amongst children and teenagers, but there are other things getting in their way, you could say.
We've talked a lot about co-creation in this seminar, so that really sounds like the right way to go to kind of get what works for them. So that's sounding like a really good strategy. I want to round off with a final question. How can people who are interested in supporting Generation PEP get in touch and get involved?
Well, visit our website and see what you can get inspiration from there, of course. And we are not interested in, in money or that kind of, we're not that kind of organization. We want your engagement. We want people to do things, and it's enough to do things around where you are. We know that role models, for example, that parents that are moving more around will give their children better opportunities to move more around. We can see that there is a collaboration between those two. So you start with where you are, with taking breaks yourself, by caring about young people and children around yourself. And we have a lot of tips on our website, what you can do, how you can engage. But it's about small steps, not so many big things. Just do these small things to really try to move the whole society from sedentary behavior to more physical active and better food habits, of course, as well.
Wow, that's wonderful work and really hope inspiring for the future, like I said. So keep it up, and thanks for what you do. And I wish I had time for even more questions, but the nice thing now is you mentioned nutrition, and that is the topic that we will be following up with now. So thank you, Carolina. We will now move on to our next speaker, who is a combination of speakers, actually. So we will be hearing from Rikard Landberg, who is professor at the Department of Biology and Biological Engineering at Chalmers, and his colleague Fredrik Bäckhed, who is professor at the Department of Molecular and Clinical Medicine at the University of Gothenburg. So we actually have the privilege of having Rikard with us physically on stage here. We are very carefully holding a distance, but nice to see you here, Rikard.
Thank you very much for that very nice introduction. It's a pleasure to be here. And as mentioned, I'm here, and Fredrik is from home. I see you there. Great. So today we are going to talk about our research and how this research in diet in relation to health and gut microbiome in relation to health meet each other, and also discuss future possibilities in this area, not the least between our groups and our institutions. So first, I would like just to set the scene a little bit on what we are addressing here. We are really, both with diet and gut microbiome research that we are both doing, we are very interested in the role of these factors when it comes to cardiometabolic diseases. And the reason for that is that cardiometabolic diseases, as we refer to, it contains type 2 diabetes and cardiovascular disease and the risk factors. And the reason for that, why we focus on this, is that this is a main killer around the world. So cardiovascular disease kills around 70%. It accounts for 70% of the total mortality in the world. But this is, of course, striking, but it's also the fact that these diseases are very much affected by modifiable risk factors, such as diet and gut microbiome. So that gives a huge potential for prevention of these conditions by the right diet and other lifestyle strategies. And this is just what I put these risk factors into a context with this slide. It shows that actually diet comes as one of the most important risk factors for cardiovascular disease and diabetes. And you can see that it's even further on compared to blood pressure. So it's a major risk factor, and it's a risk factor that we can really modify. But then you might ask yourself, don't we already know what we should eat in order to be healthy? Well, that is partly true, and that is translated into dietary guidelines. And in Sweden, we have national dietary guidelines, which are built on Nordic nutrition recommendations. And people out there, they have a perception of the dietary guidelines that this is something that the National Food Agency come up with. But actually this is a result of a very systematic investigation into the current status of the science in the field. So actually the dietary guidelines are revised every 10 years approximately, and this is now the year where we have a revision ongoing, and it involves more than 100 scientists all over in the Nordic countries to look over the scientific literature in a very systematic way to come up with the current evidence that will be the basis for the dietary guidelines. And or the nutrition recommendation that is then translated by the agencies into the dietary guidelines, because we don't eat nutrients, we eat foods. And this is very well translated into the dietary guidelines, and they look like this in Sweden. A big problem with the dietary guidelines is that just 1 out of 10 follows them. So you can blame the dietary advices, but if you don't follow them, of course, this is a major problem. Another issue here is that much of the evidence is also relying on observational studies. And observational studies, they have quite some challenges. But I used to bring this as an example, actually, because there are also randomized control trials and evidence from what we should eat in order to be healthy based on randomized control trial data. And this is actually the largest randomized control trial that has evaluated food components and the role of food components on hard disease endpoints. And as you can imagine, it is difficult to do such studies because it's difficult to get people to eat something special for a long time or period and then study how that affects disease. It requires huge studies over a long time. And this was actually what was conducted in this particular study. So they had more than 7,400 people that were randomized into 3 groups. And in one group, they had a Mediterranean diet, quite low-fat Mediterranean diet. And they compared that type of diet with a diet where you added either olive oil or nuts. And they showed just very fast after starting this that there was a tremendous impact of this small amount of olive oil and or fat or nuts that was added to the diet. So it decreases the outcome of cardiovascular events with 30% compared to the control group. And that just shows an enormous potential of a small dietary modification, what kind of impact that can have on health outcomes. What I should say is that these type of studies are very rare. What is more common is smaller intervention trials where we study the effect of specific dietary components in relation to risk factors of these diseases, because such studies can be conducted on a shorter time frames. The problem with these studies is that they only reflect effects on risk factors, and that's not disease endpoint. And another problem is that the results are typically quite mixed from these studies. So it's difficult to get a unified picture on what is the exact evidence for a specific dietary component in relation to an outcome. And there are many reasons for that. One reason is, of course, the studies are typically quite small. They are also typically conducted in different populations, which are at different risks. They are including people with different types of health statuses. And also one very important factor that has been very much neglected, I would say, is the fact that they consider diet or food items as food items and not just taking into account the fact that the way we produce food will affect not only the composition of the food, but also the way that nutrients and bioactive compounds are liberated in the food. And that will also have impact on the metabolic responses. But it's very seldom taken into account. And then we have the fact that individuals respond very differently to the same type of diet. And this is something we will come back to. And that leads us to the question, actually. Shall we go on with the type of dietary guidelines that we have today, which are based on general advices for everyone? We know that just 1 out of 10 follow these type of guidelines. We also know that there is a tremendous difference in response to the diet that we give. On the other side of this scale, to provide either general nutritional or dietary guidelines, we have the total personalization, which is basically a situation where we tailor the diet for the individual based on the individual's health status, based on his or her lifestyle, based on the desires to do different things and so on. So that is on the other extreme. It requires a massive sampling of the person's features, so metabolic status, behavior and so on, and that requires massive data collection. But we have a situation in the middle also, which we refer to as group-based nutrition, which is a situation where we can do some kind of a personalization based on whether we belong to a certain group or not. So basically, if we have a specific risk of a certain disease, for instance, or if we have something in common that gives us a differential response to a diet. The challenge with group-based nutrition is that we need to think over what kind of data do we need to collect in order to be able to do this grouping, to recognize if a person is a group A or if it's a group B person. And to do so, we need to find biomarkers of the groups, basically. And to be able to do that, we need to collect massive amount of data. So we need to use data from different sources in order to differentiate whether you are group A or a B, basically. And one factor here, which has turned out to be very important for that kind of grouping to respond and non-responders, is the gut microbiome. And because the gut microbiome has a tremendous importance when it comes to modifying the risk of cardiovascular disease. And it's also, of course, very important to collect that kind of information to better understand how also microbiome and other lifestyle factors interact to modulate the risk of these diseases. And with that, I leave the word to Fredrik, who is one of the experts and world-leading experts in the field of gut microbiota and its relation to cardiometabolic diseases. So please, Fredrik.
Thanks, Rikard. It's really an honor to be here today. Fortunately, I can't be there in person, but as you probably know, that my really favorite topic in the world is the gut microbiome and the relation to cardiometabolic health. I was under the impression that the slides would be shared from Chalmers, so I hope that Rikard can help me advance the slides.
I do.
We like to view the gut microbiota, the living organisms in the gut, as an organ by its own right. And it's quite fascinating if you start to take into account that the microbes are relatively small, that we have actually more bacteria in our guts than we have human cells in the body. So on a cellular level, we are less human than bacterial. And since each bacteria has its own genome, we also have vastly more bacterial genes in the human body than we have human genes. So we think that we should view the gut microbiota as an organ on its own right, weighing as much as the liver. And that will, of course, can have profound effects on our health. So if you move to the next slide, Rikard. So it's also important to take into account that as a popular field for the past 15 years, has been tons of different studies that can associate the gut microbiota to virtually any disease you can think of. And the main thing here is that we have to separate association versus causation. So does the microbiota contribute to a disease, or is it just reflecting a disease? So in order to do that, we felt that it was very urgent to us to understand what's normal. How does the normal gut microbiota look like? And we took advantage of a big study conducted by Göran Bergström and Mattias Wilén. It's a multi-omic study where we follow 100 healthy individuals, Swedish individuals, over 2 years, with sampling quarterly the first year and then 2 times the second year. And we, of course, then focused on the gut microbiota over the first year here. And we had to remove about 15 patients or individuals from this study because they took antibiotics during this year. So we focus on those individuals that have no diseases, considered healthy, and had not taken antibiotics over the first year to get a baseline on the gut microbiota. So if you move to the next slide, please. Thank you. And if we look at this at the panel in the middle here, it basically reflects the gut microbiota in one individual at one time. And then we connect each individual and his or her time points with a line. And what I think is quite obvious to see is that most of the individuals seem to group together, or samples within an individual seem to group together. So we confirm what's been shown previously, that the variation within an individual, so within these 4 samples, are more similar than between individuals. So you have a gut microbiota that is more similar to yourself than to anyone else on average. But that doesn't mean that we are identical. I think this is something we have to take in relation when we want to do this personalized medicine, that we may vary within an individual over time as well. And if you look at the right-hand side of this slide, you can see that there's some that are very consistent. Those are the brown ones that do not vary at all, basically, over this year. And on the other side of the panel, in the green scale, you see individuals that vary as much within he or she herself than with any other participant. And of course, will be extremely important to understand what does this variability means. So it's hard to be general in saying that the gut microbiota is that or this or that. But also the gut microbiota is a collection of organisms. And if you move to the next slide, I've made two examples of two bacteria, Faecalibacterium, which is one of the most prevalent and abundant bacteria in the human gut. And you can see that it can vary as much as tenfold within an individual over this year. But if you go to the other extreme, to Enterobacteriaceae, which is a family of bacteria with such bacteria such as E. coli, you can see that they vary up to 10,000-fold within an individual over a year, which make them very hard to use as biomarkers. So there's, of course, a lot of environmental factors that can affect the gut microbiota. And here's a few, such as medication, and we'll come back to that. Cold. We are getting an interest in exercise, for example, in relation to what Carolina talked about previously. But diet seems to be one of the main modifying factors of the gut microbiota. So we are characterizing the gut microbiota, as I told about just a few slides ago. But the microbes can also use these dietary components to produce bioactive metabolites that can then signal to the rest of the host. And that's why we think we should consider the gut microbiota not just as any organ, but as an endocrine organ that can signal to the rest of the body. So as we talked about in the beginning, both me and Rikard are very fascinated by the etiology of different cardiometabolic diseases. And these are, of course, on a stretch of a panorama, starting with usually with obesity and then ending up with cardiovascular disease. And my group has been particularly interested in trying to understand why does not everybody with risk factors such as obesity develop type 2 diabetes? Why are some healthy? Can the gut microbiota be one of those factors? So a few years ago, actually almost 10 years ago, we initiated a study where we wanted to see if the gut microbiota was different in subjects with type 2 diabetes. And we and another group, and there are several groups after that, has actually found that if you have type 2 diabetes, you seem to lose a group of bacteria called butyrate-producing bacteria. And the Faecalibacterium personificus, as I mentioned in the beginning here, is one of those bacteria we lose. But we also have to take into account that medication may miscue this. And the studies I referred to were cross-sectional. So we basically compare and contrast a patient with type 2 diabetes with a healthy control. And of course, it's not only the disease that differs, it's also the medication that these two individuals take. So we and others have found that drugs such as metformin, which is a common diabetes medication, shift the gut microbiota. So this has led us to make a pretty big endeavor together with Göran Bergström's group to focus on understanding how does the gut microbiota relate to type 2 diabetes in individuals that are not yet diagnosed with the disease. So in order to do that, we piggybacked on a very famous Swedish study called SCOPIS and made a similar design where we called 50 to 64-year-old individuals. We in total sent out more than 26,000 letters. And we had over 5,000 individuals responding, coming to the clinic where they were subjected to an oral glucose tolerance test to see if they had prediabetes or type 2 diabetes. And we then selected individuals that had prediabetes, type 2 diabetes, had normal glucose tolerance, but also normal glucose tolerant, but with a high risk factor, such as a sedentary lifestyle and unhealthy dietary habits. And we made a little cohort of about 2,000 individuals that we studied for if they had an altered gut microbiota. And we did an interim study looking at about 1,000 individuals, and we could then validate that in another 500 individuals. And this was work led by Tony Wu and Valentina Tremaroli. And once again, it's a complex plot here, but if you look at the left-hand corner, that we basically see that if we take the gut microbiota as an entirety, we see that the type 2 diabetes microbiota are different from those that have normal glucose tolerance, the light green one. And the prediabetes group in blue are in between. And what we do see again is it's a loss of butyrate-producing bacteria that is really driving this difference. And if we want to become a little bit more philosophic, and we take the next slide, we think that this relates to the Anna Karenina principle, that all happy families look the same, but each unhappy family is unhappy in its own way. And if we take that into a microbial composition perspective, we think that all happy or healthy microbiomes are rich in these butyrate-producing bacteria, but as they deteriorate, they start to get blooms of different pathogenic bacteria. And this is something we are very interested in trying to identify which are these bacteria and can they contribute to disease, or can we supplement with the butyrate-producing bacteria and restore the ecosystem. But it's also important to say that this is generally associations. So we use something called germ-free mice. These are mice that have no bacteria to address if the microbes can contribute to disease. In this case, we colonized germ-free mice, if you move to the next slide, with bacteria from individuals that were matched. So either we took a normal glucose tolerant individual that we matched with a type 2 diabetes individual based on sex, age, and BMI. And we then colonized mice with each microbiota. We replicated this in six sets of human beings, generating a pretty big cohort of mice that we followed over 12 weeks, if you move to the next slide. And we see that the mice that were colonized with type 2 diabetes microbiota, they gained a little bit more weight. They start to get a little bit of more high fasting glucose, but in particular in the later ages, they got a high insulin response. And this is typical for type 2 diabetes. You start by having a normal glucose tolerance, which means that your blood glucose can be controlled with relatively low levels of insulin. And then as the cells respond worse and worse to insulin, this is the B there, you need high insulin levels to control the fasting glucose. And eventually you start to see that the insulin cannot really suppress the glucose. So you have high glucose as well. And then you have a collapse of the beta cells. So you have high glucose, low insulin, and eventually both mice and humans will die. And what we found in the end there was that type 2 diabetes was more induced in mice that were colonized with the human microbiota from subjects with type 2 diabetes. So we do think that the microbiota can be one contributing factor to disease development. Yeah. So I just want to show you one slide, and that's how modifiable the gut microbiota is in terms of diet. And if Rikard move to the next slide, what we did here is we changed the microbiota in 10 individuals, obese individuals, by basically asking them to stop eating carbohydrates. So you only had 30 grams of total carbohydrates per day. And what we find is that the gut microbiota start to change within 1 day of this massive dietary intervention. And after 3 days, it's almost completely changed. And after a week, we have reconfigured it. And what you lose are the fiber-degrading bacteria. And in the lower right-hand corner, you see that you lose the capacity to produce short-chain fatty acids, which we think are beneficial. So this is, of course, extreme. And I will leave the floor again to Rikard, and he will talk about a diet intervention study that is a little more what you can see in real life. Thank you very much.
Okay. Thank you. So what we did actually, we were very interested in evaluating the impact of plant-based food versus meat-based diet when it comes to impact on cardiometabolic risk factors. And we also were very interested to see what kind of changes that might cause on gut microbiome and also on metabolites that are circulating in our blood in order to better understand potential benefits of a plant-based diet. Because of course for the planet it would be better if we can start to shift towards more plant-based diet. And this study was conducted in patients who had already had a myocardial infarction, and it was conducted and led by a cardiologist in Örebro, and both Fredrik and I and our group were included to do metabolomics analysis and also to do gut microbiome analysis. So what we showed here in this study, which was an intervention, a small-scale intervention with around 30 patients who had had myocardial infarction, was that we put them on a plant-based diet, basically a vegetarian type of diet versus a meat type of diet. And what we wanted to evaluate were risk factors of cardiovascular disease, mainly blood lipids, and particularly whether we can have a difference in oxidized LDL cholesterol, which is the bad cholesterol. And oxidized LDL cholesterol is an important factor for the generation of atherosclerosis. So we wanted to see, could we change this with this plant-based diet in a rather short time period? And do we also have effects on other risk factors and gut microbiome and plasma metabolome? And actually we showed that it was possible to have an effect on oxidized LDL. So it decreased once the subjects had their plant-based diet, as you can see also in this slide. Not that clear, but it was a clear effect anyway. But what we also saw, which was very interesting, is that we had a large impact on gut microbiota. So the gut microbiota in these fecal samples that were collected from these subjects differed quite substantially between the groups. And we could also see the same when it comes to the metabolites. And many of the metabolites that have been associated also with increased risk of developing cardiovascular disease or decreased risk of cardiovascular disease were changed in the direction that we expected. The big question here was, well, we can change the microbiome and metabolome based on the diet that we provide, but can we also conduct stratification based on what kind of microbiota people have at the beginning before they start the intervention? Does specific bacteria interact with the diet and give us a higher response on our metabolic factor or lower response? And is it possible to already perhaps take a fecal sample and analyze gut microbiome and pick out bacteria that will predict if a person will have a good response to a certain plant-based diet or not? And that was also something that we had an indication of in this study. So if we divided subjects into those who were responsive to the intervention and those who were not responsive, it's a rather few individuals. We had 6 individuals that responded and only 14 that did not. And then we could clearly see that those differed in some bacteria at baseline. So those who had a response had a certain bacteria present in their gut microbiome compared to those who did not respond. However, we couldn't see that there were any differences in the metabolites already at baseline that would predict the outcome. But it suggests at least that the gut microbiome could be used as a target for more personalized nutrition to get more effects out of your plant-based diet later on than if you don't take it into account. And that brings us into this concept of group-based nutrition. So it's obvious that we could probably use gut microbiome to a little bit tailor the right diet to have maximum response, beneficial response as possible. But we could also potentially use metabolome in this way, which is the number of metabolites, which is the pool of metabolites that are circulating in a blood sample, for instance. And this is our hypothesis. And we could also potentially use other types of lifestyle data to do this stratification. This is a concept that we have worked on that is called metabotyping, basically. So what we are trying to do here is to see, can we already group individuals based on the blood samples on what type of metabolites they have in their circulation into groups of individuals that will be likely to have a certain response of a diet or less likely to have that response to a diet? Or can we divide even into groups that are related to a higher risk of cardiovascular disease or lower risk of cardiovascular disease, for instance, and that will benefit more from a specific diet or less from another type of diet. And this is a work that is ongoing. So we are using data from a large Danish data set. So we have individuals, we have 628 individuals where we have data collected over a year, massive omics data and very detailed dietary data and gut microbiome data. And what we try to do in this study is basically to see, can we find clusters of individuals that are differentially related to risk factors of cardiovascular disease, basically. And can we find such with a higher precision and a predictive power than the classical metabolic syndrome grouping that is used? Another aspect of this is not only to find if we can have metabolites that predict response in a static outcome, but also to find those that behave differently in dynamic outcomes. And this is a work that we are doing together with Fraunhofer Chalmers Center, where we try to find individuals that, for instance, have differential responses to a certain food when it comes to glycemic profiles after that meal. Because we think that the profile on how you respond to a certain meal in your postprandial glucose measurements will also determine the risk of diabetes to some extent. So it's not only whether you are high and low responder, it's also a matter of how these curves look like. And we want to see, can we use metabolomics data at baseline to predict whether you are one type of responder or another type of responder of your glycemic profiles. And we are also doing this in a way which using the more complex study designs, because many intervention trials are complex in the study design, such as crossover trials where measurements are made in the same individuals over time and so on. So it requires specific data handling strategies, which is something that Fraunhofer Chalmers centers are really expert in, and it's a very good opportunity for us to collaborate with them. But that kind of metabotyping is utilizing a large number of metabolites from metabolomic experiments, but we can also use more simple measurements. And as Fredrik said, there is a consensus that butyrate producing bacteria, the presence of such bacteria is associated with lower risk of diabetes. But a big question is also whether butyrate per se in the circulation could modify the risk of diabetes. And we are currently investigating that in a trial where we are trying to develop both a tool in order to be able to stratify individuals to high butyrate, those with high butyrate concentration and those with low butyrate concentration. And our hypothesis is that those with high butyrate concentration will be the one that will be most benefiting from a dietary fiber intervention to prevent pre-diabetes going into diabetes later on. And this is a study that we are going to investigate to do together with colleagues in China, but of course, one of the prerequisites is that we can analyze things, what we are investigating. And short-chain fatty acids in blood samples turn out to be something. It sounds very easy to analyze that, but it turned out to be something very difficult, actually. So we have worked for several years to establish a very sensitive method here at Chalmers that we can use for this purpose. And this method is now used to develop a challenge test where we can see whether individuals are high butyrate producer, low butyrate producer, ending up with high concentration or low concentration of butyrate in their blood samples. And that will be used for the basis of dividing individuals into high producers and low producers, and then run an intervention with fermentable dietary fiber in pre-diabetics to see if we can really have strong impact. And our hypothesis is, of course, we have stronger impact among those who have high capacity of producing butyrate. As a control, we also want to include oral supplements of butyrate to see if it also depends if the butyrate is produced from the fiber or if it's provided orally. So this is something that is currently ongoing. But these are all group-based nutrition strategies. What about personalized nutrition in terms of really taking advantage of the individual's physical setting and performance and desires and activity and so on? And actually this has been done in only a few studies because it requires massive resources to be able to do such studies. And one of the key studies here is the study by Sevi et al., where it's really a landmark study that opened the complete field of personalized nutrition. And what they did basically a couple of years ago was that they had 800 people which they followed and collected massive amount of data, gut microbiome data, diet data, lifestyle data. And what they did from this was also that they measured postprandial or they measured glucose response to diets. And what they did was that they developed models algorithm to model individuals' response to diet and lifestyle, and really find the key determinants per individual on what modifies that person's blood glucose levels after a meal. So they can come up with advices for individuals how they should behave, basically to keep their blood glucose levels low after a meal. And they also validated this in a smaller trial to see that it really worked. And that was very efficient because if you can modulate the person's response to glucose, you can modulate the risk of developing diabetes, because these are related. This was followed up by another large international consortium called the PREDICT Consortium, and what they did was that they did not only focus on postprandial glucose levels, trying to individualize, they also measured postprandial lipid profiles and also insulin responses through C-peptide measurements. And they did a similar setting, basically, where they had people at the clinic eating standardized diet, and then they went home and they recorded a lot of information about how they were eating and what kind of bacteria they had in their intestine through gut microbiome analysis and other lifestyle measurements to build these algorithms for personalization. And you can see there is, if you look into blood glucose levels, there is an enormous variation caused by meal composition, for instance. So the form you eat your carbohydrates, for instance, affects a lot, and also the microbiome and other factors. But this is something that has been conducted in trials focusing on postprandial glucose and lipid profiles, but there is much more to do. And as a summary, I would like to say that diet is a modifiable risk factors, which is very important for mitigation of cardiometabolic disease risk, gut microbiota as well. The interaction between the two is super important, and it's also it will modify metabolic responses and is therefore an important target for personalized nutrition. And we think that we have a very good setup here to competence and infrastructure and motivation to jointly develop data-driven precision prevention strategies based on diet and microbiota. And that brings us to what we want to do in the future now, because this was based on what we have done mainly. It brings us to this opportunity that Vinnova has now for innovation milieus, where they fund the milieus for 5 years with 8 million a year. And we would like together to establish such an environment where we target, where we use precision nutrition for disease prevention and health promotion. And the vision here is really to establish a leading international environment where we can develop efficient strategies for precision prevention of cardiometabolic diseases through nutrition, gut microbiome, and lifestyle using data-driven approaches. And the actors here are Chalmers, Göteborgs, Gothenburg University, RISE, Fraunhofer, Chalmers centers, and we also hope to get the region involved. And there is a number of companies that are also interested in this. And the key target is prevention of cardiometabolic diseases, targeting reversible preconditions such as prediabetes, cardiovascular risk factors, and body weight management. We are also targeting health measures such as sleep, physical activity, appetite, and stress. And this will be done by using the advantage of ongoing activities already, but also we will together do a joint trial where all these competences come together, and we co-create new ways of doing personalized nutrition based on gut microbiome, nutrition, and lifestyle data. And we are a number of people. These are the group of Fredrik Bäckhed, and these are some people from my group and some of the collaborators. And of course, we are very happy to collaborate also with RISE and Fraunhofer Chalmers Center and the region, not the least through this new initiative that we hope to get funded also. It's a tough competition, as you know. We'll see. Thank you.
Thank you very much, Rikard and Fredrik. That was interesting and at a very high detail level. I have received one comment rather from the audience that I think perhaps you can comment briefly on, Rikard. The statement is, vegetable oils are horrible for your health. It increases oxidative stress. What's your response to that statement?
Well, they are sensitive to oxidative stress, but they're also antioxidants, and this is not true. I mean, if you look into epidemiology, we can talk about that for a long time, but what you basically see in epidemiology is that it depends very much what you replace it for. And if you replace starchy diets, for instance, for unsaturated fat oils, it is beneficial for cardiometabolic health. Whereas if you replace, if you instead of eating starch, eat saturated fat, it's also better. But if you take unsaturated fat instead of saturated, you have also decreased risk of cardiovascular disease. So it doesn't turn out to be the case that they are horrible for health if you look into the scientific evidence. It's not true.
Thank you. Fredrik, I'll run off with a question for you. You mentioned before that when you do a drug intervention to shift the gut microbiota, I started thinking about how long does that take until you find what works for that individual, getting the personalized medicine there. You mentioned before that when you replaced all the carbohydrates, you saw a difference within 3 days. But how about if you have a patient who is getting a drug intervention? Because then you're adding rather than subtracting.
Well, that's a great question. We haven't done that on drugs. We have done it on metformin, for example, but then we took the first sample 2 months after the drugs were initiated. So, then we saw a complete change. So I would guess that we would see differences within days, and then maybe it takes time for restructuring the microbiome. We have seen similar things for statin, but that's not also, we have sort of not taken the opportunity yet to do a longitudinal study to see when does this change occur first.
Okay. Thank you very much. I'm afraid that is all the time we have for questions, and I just want to congratulate you two to a very interesting and varied study. So good luck with the continuation.
Thank you.
Let's see now. Martin is going to present our next speakers, who are actually here in Rivnan with us. So let's see. I will exit that way, and you direct them to where to go.
Thank you, Cecilia. Yes. I'm very happy to invite our next two speakers. It's Sara Svedlund, Chief Physician at the Department of Clinical Physiology at the Sahlgrenska University Hospital. She's also Associate Professor at the Department of Molecular and Clinical Medicine at Sahlgrenska Academy at the University of Gothenburg. And together with her, we have Helle Wijk, who is a registered nurse at Sahlgrenska University Hospital, and a professor at the Institute of Health and Care Science at the University of Gothenburg. But Helle, you're also visiting professor here at Chalmers at the Center of Healthcare Architecture. Very welcome, both of you. And we're very eager to hear about the heart bus. So without further ado, I will leave the word to Sara.
Thank you, and thank you for the introduction. So the heart bus is also a collaboration between AstraZeneca and Sahlgrenska University Hospital, and it's about characterization of heart failure in patients' vicinity. So we are an ongoing study and actively recruiting. So today's talk will be about some background on the study. I will give you an update on where we currently are. And also then later Helle will tell us a little bit more about the sub-study that we are conducting on the heart bus with respect to the healthcare environment. So I will start by giving you a background on some challenges that we are facing in healthcare today when it comes to heart failure. So heart failure is likely underdiagnosed. So when we talk about healthcare, heart failure in healthcare, we talk a lot about a common measure called ejection fraction. So this measure is used to describe the left ventricle pumping ability. So if this pumping ability is reduced, we talk about heart failure with reduced ejection fraction, or HFrEF. So on the other side, we have heart failure with preserved ejection fraction. Then instead, it's a problem in the left ventricle with the relaxation. So to be able to tell something about which type of heart failure we are dealing with, we need advanced diagnostics. And this is because different treatment options are available depending on the type of heart failure. So we need access to imaging, and that is echocardiography, so ultrasound of the heart. We also need access to chemistry, laboratory chemistry analysis, and a common blood sample that we analyze in connection to heart failure is NT-proBNP. And preferentially, we also need some kind of diagnostic test to describe the patient's physical capacity. So, for example, the 6-minute walk test or like a cardiopulmonary exercise test. So further, it's a huge problem for us in healthcare today that we don't have any evidence-based treatment for the condition HFpEF. So in an attempt to overcome these challenges, so we developed the heart failure bus, the heart bus. So the heart bus gives us the possibility for advanced cardiovascular diagnostics on a mobile clinic. So actually what we did is that we put all these advanced diagnostics that we need on a mobile platform which we take out to the patient. So a patient can be examined in vicinity. And this provides us with a faster basis for evaluation of heart failure. And today we have recruited in the study 67 patients. We started recruitment last year in mid-October, and our goal is to reach 200 patients. So we are ongoing and actively recruiting. We have learned a lot so far about how to approach primary care and try to recruit patients. And also we are trying to answer our main and very important research question: which important mechanism can we identify using this characterization study with deep phenotyping with patients with different kinds of heart failure, so that we can identify these mechanisms and in the long run try to facilitate a development of novel treatments, and then particularly for patients with HFpEF. So also in parallel with the research study, we are also conducting an innovation study at Sahlgrenska University Hospital, where we try to see, is the concept that the heart bus provides us with something that we can take back into healthcare routine? So is the concept that we gather all the diagnostics around the heart failing patient, is this something that we can take benefit from and try to adapt into a healthcare situation? So let's take a tour on the heart bus. So here you can see an overview of the heart bus facility. So you see right away that it's actually not a bus, it's a trailer. So it's 70 square meters, so it's quite large. And actually the examination rooms that we have on the heart bus is full size. So they are basically the same size as the examinations rooms that we have at the clinic where I work at Sahlgrenska. And you can also see that there are two lateral wings, so one here and one here. So these wings go out and then they are folded back together when the heart bus is in transport. So let's go in. So now we have made it through the main entrance, and here you can see our waiting area. So we have some chairs and there is a small kitchen. And this is where we do the patient registration in the study. And also we have the possibility for some personal privacy. And then we take a move into our first examination room, which is our cardiac ultrasound room. So here we have a high-end ultrasound machine where we can do an extensive protocol with 2D imaging of the LV and also the right ventricle. And we have the possibility to all kinds of advanced analysis when it comes to describing the pumping ability of the heart, for example, strain analysis. And we also have the possibility to do a 3D volume assessment. And in connection with this extensive ultrasound examination, we also do something called a stress echo. So during a stress echo, we infuse a pharmacological stressor called adenosine to increase the heart rate a little bit and also the contractile demand of the heart. And this we do to assess how the heart is working during physical exercise or that is then stress. And in connection to the stress echo, we perform a special examination called coronary flow reserve. So coronary flow reserve, it's a composite measure which gives us information on both the epicardial artery function in the coronaries, but also very importantly, it gives us information on how the microvessels in the heart is working. So impaired microvascular function is something that we have seen in our previous studies is very important as a mechanism for HFpEF. And when we do the stress echo, we also need to have surveillance equipment in place for monitoring of ECG and the pulse and blood pressure. And in our protocol, we have also included several different non-invasive vascular function assessments. So this is an example here, and it's a detailed analysis of pulse wave velocities. So pulse wave velocities are affected in degree with increasing appearance of atherosclerosis. So let's move on to our next examination room. And this is our functional assessment room. And in this room, we do an exercise ECG at the same time as we study the pulmonary function. So this is called a cardiopulmonary exercise test. So we analyze the breathing air that the patient consumes during exercise, and then we can get very detailed data on the breathing reserve. And we can also say something about the functionally limiting organ system. So in a normal physiological situation, this should be the heart, but if you have some problems with your lungs, this may also impair your breathing reserve. And we get a detailed objective measure of the functional capacity of the patient. And at the same time, we monitor in real time a full 12-lead ECG, so we can also look if there is any signs or symptoms of arrhythmia or ischemia on the ECG. And the CPET examination gives us a lot of information about the patient's physical capacity status. So here we have the possibility to do many advanced offline analysis. So let's proceed, and we will go into our lab area. And here we have everything we need for blood sample handling. And also we have all necessary equipment to take care of some blood tests ourselves. So actually, which I think is very cool, is that we have the possibility to analyze some point-of-care laboratory analysis ourselves in connection with the patient visits on the heart bus. So for example, we can get a value on the NT-proBNP value, which is very important in heart failure during the patient's visit in the bus. But also we send blood samples for analysis at clinical chemistry at Sahlgrenska. And then the next room will be our staff room. So here we have one physician, 2 biomedical technicians, and 1 nurse working on a daily basis on the heart bus to collect all the data and take care of our patients. So here you can see the overview of the heart bus facility. My first impression after being involved in the development of the facility was that this is a really huge bus. It's it feels very large when you enter it. But now, 67 patients down the line, I can for sure say that we use these 70 square meters very optimal, because we of course need to store everything, and also we need to have access to our consumables, etc. So But with this in mind, we put very much detailed effort into creating the environment on the heart bus. So everything from the color of the wallpaper to the lighting to how we have furnished the examination rooms. And therefore, I'm very happy for the collaboration that we now have established with Helle regarding the healthcare environment. So please, Helle.
Thank you very much, Sara, and we are so happy also to be part of this project. What we are including is two qualitative studies, and the benefits of a qualitative approach is that it captures the patient experiences, which in this study adds an opportunity to gain knowledge of how the patient experience shortness of breath, as well as how they perceive to be diagnosed in a healthcare environment like a mobile clinic. And the first study, as you see here, is run by Jonna Norman, who is a PhD student, and Lena Björk, who is an associate professor at the Institute of Health and Caring Sciences at Sahlgrenska Academy, as well as the Sahlgrenska University Hospital. And the rationale for conducting this study is that little is known about how the physiological signs that we just heard here about from Sara relates to the subjective symptoms experiences in persons diagnosed with heart failure. And these subjective symptoms are difficult to assess with traditional instruments and classifications. What we do know, though, is that shortness of breath has a negative impact on quality of life as well as on the prognosis of the diagnosis. The better, there is now an assessment tool called the Experiences of Breathing and Shortness of Breath, which measures several dimensions of the personal shortness of breath experiences, and now that is added into the Heart Bus project. As you can see here, the instrument includes open-ended questions where the patients are asked to elaborate on their own experiences of shortness of breath and also about their symptom management strategies, as well as questions about the frequency, duration, and the perceived causes of the breathing symptom. The other qualitative study is run by me, and as you heard in the presentation, I also come from the Health and Caring Sciences and Sahlgrenska University Hospital, but I'm also happy to be a visiting professor at the Center for Healthcare Architecture. And the rationale for this study is based on the knowledge that how the patient perceives the healthcare environment is crucial for the patient's perception of confidence and quality of care, and also their sense of patient safety. And this is well in line with the person-centered approach, which is a global imperative in healthcare. And according to a person-centered approach, it is stressed that the design of the healthcare environment should be able to strengthen the patient's self-esteem, independence, and also well-being, which covers both the objective feature in the rooms that you have seen now in the guided tour by Sara, but also how well the physical healthcare environment also creates a psychosocial dimension of person-centeredness. What we know from previous studies is that there is a relation between how the patient assesses the quality of care and the actual design of the physical healthcare environment. And there is an instrument, the Person-Centered Climate Questionnaire, that is a validated patient-reported outcome instrument designed to evaluate the extent to which the physical environment is perceived as being person-centered. And that instrument we are now using in the Heart Bus project. And the instrument comprises 3 related domains: safety, everydayness, and hospitality. So for us, the Heart Bus project is a unique opportunity to investigate how subjective experiences of symptoms in different types of heart failure and to explore where the variations in symptoms experiences can be related to the physiological signs of heart failure, and also to evaluate how it is for the patients to be assessed in such an environment like the Heart Bus clinic. And we think that the results will contribute to safer symptom assessment with positive implications for both patients and professionals, as well as gain further knowledge of how the patient experience of being assessed in an environment as the heart bus, which is important for assessing future opportunities within the frame of integrated care.
Thank you, Helle. So I would like to highlight the clinical research team working in the heart bus for an excellent job in connection with the patient recruitment and also the data collection. So from the left we have Alexandra, Stenko, Henrik and Eva. And I'm very sure that we will keep up the good speed with the recruitment so that in hopefully 1.5 years we will have reached our goal of recruiting 200 patients. And I'm very positive that we will have a lot of exciting data coming out from this project. And also I would like to thank the study team at AstraZeneca and all the involved supporting functions at Sahlgrenska University Hospital for making this study happen. So thank you.
Thank you very much, both Sara and Helle. This was, I think this is an amazing project with a lot of different aspects to it. We got one question from the audience, and I think you already answered that, Sara, in your presentation, but I will ask it anyway. So do you think you could make this smaller, like a heart ambulance in some way, or do you need all the space that you have?
I mean, yeah, we have been doing a lot of thinking on this because now we have made some initial learnings, and I mean the current heart bus has its very great advantages in being full size. Actually, it makes it a little bit more harder to move because we can't park in every possible place. So the idea then would be to make a smaller version after this initial pilot maybe. Mm-hmm. And also then to downsize a little bit on the protocol because now, I mean, the goal is to be very extensive and really go for deep phenotyping. So then for sure this kind of trailer is necessary, but maybe we will need to create a mini version.
Mm. No, it's about 3.5 times the size of my first apartment when I moved there as a student. So it's, but it seems like a perfect combination of functional assessment and detailed analysis of the heart with a well-equipped lab. So that's quite impressive, even though it's only 76 square meters or something like that. We are soon to have a lunch break, but I also have a question to you, Helle. You talked about the perceived quality of care. And obviously that's extremely important with the patient in center, but do we know anything about the relation between the perceived quality and how that actually influence the treatment itself, or if patients are getting better? Do we get better by feeling that we are treated in a better way?
I think the relation in this sense is related to this environment, because there you are in the center as the patient, and we know that patient participation is very crucial, right, for the quality of care and also for the outcome of care. So I think such a healthcare environment can really support patient participation, and that is important.
It will be extremely interesting to learn about the outcomes of these studies. Thank you both for coming. I'm afraid that's all the time we have for questions now. But again, we're really happy that you accepted our invitation and also that you came here today to present. By that, we should go for lunch, for leg stretch, or for any other activity for about 58 more minutes. And we will see you back here at 1 o'clock, where we will start looking at virtual reality and augmented reality for psychiatry. So that will be very interesting, I think. So stay tuned. But first, a lunch break.